Hi, today we are going to talk about water, H2O. A famous writer, professor, and noted scholar once said, if there is magic on this planet, it is contained in water. In the video today, we're going to try to answer the question, how is the structure of water responsible for the magical properties of water? And let's look at the chemical formula, H2O. So water is a compound, and if you remember, a compound is defined as two or more different elements chemically combined in a fixed ratio. So we have two different elements, hydrogen and oxygen, and they are in a fixed ratio, two hydrogens for every one oxygen. So how are they chemically combined? Are they chemically combined by ionic bonds, by polar covalent bonds, or by nonpolar covalent bonds? So let's first take a look at the two elements as they sort of appear in the periodic table. So over here we have hydrogen, and over here we have oxygen. As we can see, hydrogen has an atomic number of 1, and you already know that that tells you hydrogen has 1 proton. Because we're calling this an atom and not an ion, this hydrogen has no charge, so the number of electrons must equal the number of protons. So therefore, the hydrogen atom also has 1 electron. So if we were to take a look at the atomic structure of hydrogen, we would see it has 1 proton in the nucleus, it has no neutrons. We could get that from the mass number, and it has 1 electron, so it only has 1 energy level electron shell. So the question is, well, is hydrogen a stable atom? And of course the answer is no, because to be stable it must have a full outer shell. And its first shell, its only shell, is its outer shell, has 1 electron. And how many electrons is needed to complete its outer shell if it is the first shell? And you're absolutely right, the answer is 2. So hydrogen needs 1 more electron to become stable. So hydrogen is reactive. In other words, it will seek to form bonds with other atoms to fill its outer energy level and become stable. So right now, based on this atomic structure, we could say hydrogen is unstable and reactive. When we look at the oxygen's atomic number, we see that it has an atomic number of 8. And again, because this is not an ion, it's an atom, it has a neutral charge, so the number of electrons will be equal to the number of protons. So it also has 8 electrons. So if we take a look at the atomic structure of oxygen, it has 8 protons in its nucleus, and we can figure out that it has 8 neutrons from the mass number, which rounded off is 16. And we know that the protons plus neutrons has to equal 16. So 8 plus 8 is 16. Okay? But we're getting that it has 8 electrons because electrons equal to the number of protons, and the atomic number of 8 tells us that we have 8 protons. So when we fill in the shells of oxygen, the first shell can accept 2 electrons. So 2 electrons are in the first shell. The second shell can fill 8. but there's only 6 left over in oxygen because 2 of them already went to the first shell. So we have 6 left over, and they go into the second shell. 1, 2, 3, 4, 5, 6. But we need 8 to complete that outer shell. So we need 2 more electrons to fill that outer shell in oxygen. So oxygen is also unstable and will react with other atoms to form chemical bonds in an attempt to fill its outer shell. So we got 2 atoms that are unstable wanting to enter into chemical reactions to form bonds and fill the outer energy level. So the question is, well, are they going to do it by ionic bonds, transferring electrons, or are they going to do it by polar covalent bonds, unequal sharing of electrons, or non-polar covalent bonds, equal sharing of electrons? Well, we could look at this in a couple of ways. We could look at the periodic table, and I'm going to put another hydrogen here because it's H2O. And when we look at the periodic table, we see that oxygen is all the way to the right, and that's where the nonmetals are. And hydrogen is an exception to the rule. It's all the way to the left where all the metals are, but it's an exception and it's a non-metal. So we know in ionic bonds we have metals bonding to nonmetals. In this case, we have a nonmetal bonding to a nonmetal, so it's going to be a covalent bond, but an energy level. So now that we know that oxygen is going to bind to these 2 hydrogens by a covalent bond, the next question is, well, what type of covalent bond will it be? Will it be a polar covalent bond, which is unequal sharing of electrons, or a non-polar covalent bond, equal sharing of electrons? Well, that depends on the electronegativity of the atom. So we need to know something about electronegativity, which you guys already know. You know it's that force or pull or attraction that an atom has on an electron. And you should know that oxygen has a very strong pull on an electron, a very strong attraction for electrons, where hydrogen has a very low electronegativity, a very weak pull on an electron. So again, oxygen has a high electronegativity. Hydrogen has a low electronegativity. So as they're trying to share this electron, the big, strong oxygen is going to have a greater pull on the electron, and it will pull the electron closer to it. So because of that, the oxygen will have a slightly negative charge, or a partial negative charge. And we use the symbol, the squiggly symbol of a negative, to show that it is slightly negative. And the hydrogen will have a partial or slightly positive charge. And we show that same squiggly sign, but with a positive. So now let's take a closer look at the structure of a polar covalent bonds in water. So let's take an oxygen, let's bring in a hydrogen, let's bring in other hydrogen. So this hydrogen is going to form a single covalent bond with oxygen. So there we go. Okay, so that's a single covalent bond because in a single covalent bond, it consists of two electrons, one from hydrogen, one from oxygen that they're sharing. But notice that the electrons are closer to the oxygen because oxygen has that high electronegativity. Let's put in the other single covalent bond between oxygen and hydrogen. And again, we have a sharing of electrons, but it's not equal sharing. We can see that the electrons are closer to oxygen. So oxygen is going to have that slightly or partial negative charge, and the two hydrogens are going to have a slightly or partial positive charge. Right? So what that creates is something called a polar molecule. And a polar molecule means that we have a molecule that has one region, the oxygen region, with a slightly negative charge, and another region, the hydrogen region, with a slightly positive charge. So because we have regions of opposite or different charges, what is called a polar molecule. And this is very important because due to water's polarity, it is able to stick to other water molecules and other substances via a hydrogen bond. And hydrogen bonds are the property of water that gives water all its magical properties. So let's take a look at hydrogen bonds. So here we have a water molecule next to another water molecule, next to another water molecule, next to another water molecule, next to another water molecule. So we have 1, 2, 3, 4, 5 water molecules. And these water molecules are actually connected or sticking to each other via these hydrogen bonds. So here's this water molecule sticking to this water molecule via a hydrogen bond. Here's another hydrogen bond connecting this water molecule to this water molecule, and another hydrogen bond connecting this water molecule to this water molecule, and another hydrogen bond connecting this water molecule to this water molecule. A water molecule can make up to 4 hydrogen bonds. So what is a hydrogen bond? Well, if we look, the partially negative oxygen of one water molecule is attracted to the partial positive charge of another water molecule. So the attraction between opposite partial charges is a hydrogen bond. Remember, an ionic bond is attraction between full opposite charges. So because the ionic bond is a full charge, it will be a stronger charge than the attraction between only partial charges. And because of these hydrogen bonds, water can stick to other water molecules, it can stick to ionic compounds, and it can stick to other polar molecules. Note, it's important to remember that within one water molecule, a water molecule is put together by covalent bonds. So this hydrogen in this water molecule is covalently bonded to this oxygen. And the second hydrogen is covalently bonded to this oxygen as well. But there's a hydrogen bond that sticks or connects this water molecule to another water molecule. So hydrogen bonds are between water molecules. Covalent bonds are within water molecules. All right, so